A very good afternoon to our teacher. Today, my group will be presenting about the assignment for the static assignment for our static group. So we start with question one. We have a design model for transmission tower. Design model for question one, we have design model for transmission line tower, which is shown in the figure A. So the question wanted us to find forces in member KL, PQ, FH, EJ, and DS. And and it says we can use a combination of method. So the method that I will be personally using for our group that I recommend is the method of join. Uh, is the method of join. So here is the FBD of the whole diagram, which is translated from the picture. Okay, so for finding the forces in each member, first I did personally was to find the moment at J. So when I find the moment at J, I will find the moment for the member of FH. Here's the moment of J. We have 25 kilonewton forces down there, and then we know we have a force here, HF. We have two forces here when we cut the joint from here. We have forces here, we have forces here, the 35 kilonewton. We ignore the forces here. So to get here, to find the moment here, we need the length we need length from the vertically up here, 25 kilonewton to H. That's how we find the moment here to find the FH. So here, all the workings here are just basically like normal mathematics to find what we needed to find the moment. So we have tangent here, which is 6 divided by 12, which is the length here, the adjacent divided by the side. You will get 26 theta, 26.57 theta, which is theta from here. And then from here you can find the length of HI here. For the length of HI here is 4.47. If you use the if you use the sin cos tangent formula. So from here we can know one thing is that HI equals to IJ equals to JK. HI equals to this one, equals to this one, equals to this one. The length was the same. Here's 4 meter, 4 meter, 4 meter. And then the height, 6 meter, was also K to J, 2 meter, 2 meter, 2 meter. So we can safely assume that the hypotenuse of HI, IJ, and JK is the same. So from here, this is just me finding the data from here for my necessary for my calculation. And then we also can conclude that H, J, and F is an isosceles triangle, which means the length of HF and the length of FJ is the same. So here we start off with finding the HF, the length of HF. Here we can use the hypotenuse formula and the sine rule formula, which is sine 26.57 Newton times with HF. Here, since it's isosceles triangle, so the angle here will be the same with angle here. So here, sine 26.57 times with HF. And then the other one will be from the angle from F, which is the angle that we found here, 63.43 times by 2, since it's 2 of it here. So here will be sine 126.86 equals to 8.84. 8.84 here is found here, actually, HI. Since I mentioned below, above, HI equals to IJ. They are both the same. So finding the angle here for the isosceles triangle, H to J is actually 4.47 times 2. So we get this value. And from here, we get HF is equal to 4.997 meter. So I rounded up into 5 meter. So now I know HF is 5 meter. And then the second one I find is HG. I have HF, which is 5 meter. I find HG. Apa tu HF? HG. I mean. So after finding HF, I proceed to find the HG, the length of HG. So with the same cosine rule, HF equals to 5 sine 30 equals to hg divided by 5, hg divided by 5, the same sign contagion rule. You will find that the x here, h until this middle that parts from g, is actually 1.25 meter. So from here, since you already have the x value and all the value that we needed, we can find the moment at j, which will help us find the force at hf. So here, moment at j equals to 0. Here we have 35 kilonewton times with its perpendicular length, which is 1.25 meter here. Sorry, 25 kilonewton. Sorry, 25 kilonewton times with its perpendicular length, which is 1.25 kilonewton, plus a 1.25 meter. Sorry, wait. Kita cut lah. So for finding the force in HF, we take the moment at J. Here we have 25 kilonewton times with 6.75, which is the length from HJ. The length from HJ, the moment is taken from here. So the force here, so the force HF is times with HJ. Bapak susah bodoh nak ni. Kat lagi. Aduh. Susah nak cakap. Sekejap, ni bukan 1.25 bodoh ni setai. Papi lah. Ya, tidur. Okay, so for finding, after we found everything we needed, we need to find the force in HF. We take the moment at J, which is here. The moment at J. And then we have two forces that we needed. Since we take the moment at J, the force of from J will be ignored. So from here we can see two force, HF and then this 25 kilonewton force. And then we take the moment at J, 25 kilonewton times with its perpendicular length, which is 6.75 meter, plus with force HF times 4 meter, which is the height here. J to H is 4 meter. And then from here, we will get negative 42187.5 Newton meter, which is also equals to 42187.5 Newton meter, but for the compression. Which means the force here which means the arrow, instead of going to the right side, is going to the left side. And since we have HF, I can assume that FQP, which is the other side of the transmission tower, has the same they have the same force. HF equals to FE. So does HF equals to QP, but in the opposite direction. So I can safely assume that FQ is also equals to the same force as HF. Now for finding KL and JE, the force in KL and the force in JE, I can assume that force in KL is the same as force in JE. So all I need to find is force in JE, and then I can eliminate that. So for finding theta here, the theta here, I take the whole height of the transmission tower, which is 30 meter, and then the horizontal length given, which is 5.4 meter. 5.4 meter. There's no doubt here. And I take half of it, which is 2.7. So tangent theta equals to 30 divided by 2.7, I get 84.86. 84.86 is the theta here. And then do some calculation, 90 minus 84.86, you can get the theta up here, which is theta we need. And then, which is 5.14. So tangent 5.14 equals to EK divided by 6. From here, I can safely assume that the point here, K prime is the force that I created here, is the marking that I created, I'm sorry. So EK divided by 6, tangent theta equals to EK divided by 6. I'll get the height, the length here. So the length of EK is 0.54 meter. And then to find FE here, since I know here is 12, all I need to do was use the whole length, 12 minus by HF, and then minus y 0.54. I will get the length of FE, which is 6.46 meter. And then for the next one, to find JE, or I use another triangle rule, which is the A squared equals to B squared plus C squared minus 2BC cos A. That's the formula I use. JE, since I have FE, I need to find JE. I have the angle here. I have the angle here. I also have the angle here from the isosceles triangle that I found. So I can find the FE. And so we do the mathematics. I found out that JE equals to 5.29 meter. And then for the next step, I find the theta. The theta here. Theta 1 is the angle that I needed, which is here. Finding theta 1 will help us to find the resultant force. So we find the theta 1. We find out theta is 77 degree. Theta 1 equals to 77 minus 36.86 degree. 77 minus 36.86 degree, which is the angle that we found just now. It's somewhere up there. Here. Here's the angle. You do some rough mathematics, you can find out they share almost the same angle for the whole thrust. So we know that theta 1 equals to 40.85, which is here. Here, up here. Down here is 49 something. Okay, so we have all the necessary information for us to find the forces. I start with moment at h. Moment at h equals to negative 25k times with its perpendicular length, which is 1.25. And then JE here, moment at here, the force here times with 1.25, and then JE times with each respective perpendicular length. Since I already found the theta, so it's FJE cos 40.85 times 8 minus FJ sine 40.85 times 4, which is this 8 and 4 is the respective perpendicular length. So here we found out that FJE equals to 3605.3 Newton compression. Since this is negative, the extension is compression, which means my arrow, I need to reverse my arrow. That's all. And to find Kj, I use the equation of equilibrium, the sum of Fy. The sum of Fy here. Fkj cos 63.43 minus 25,000 Newton minus 3605.3 cos 40.85. I'll get Fkj equals to 49795 Newton, which is here. For finding Ka, since we know that Fkj equals to Fkl, Fk is also equals to Fku. This tangent theta 0.54 is the same thing I explained just now to find the theta here. And then we use the equation of equilibrium, sum of Fy. Here since we have all the forces that we found just now, so it's just a simple matter of plus and minus. This one plus this one minus this one minus this one is written here. Yeah, and then we found out that Fka equals to 223.62 Newton, which is here. 223.62.8 here. For finding ds, we have the force that we found just now, the force member that we found just now, and this is the Freeburg diagram. Same step as usual. 5.4, since they share the same angle all the way here. C prime is here, divided by 6, which is the height given at the very start of the height given at the very start of the equation. So we found out that the length here was 0.54. Here is 0.54. And the tangent theta equals to 2.7 divided by 6. 2.7 is the height here. Here. The length from C prime to S is 3.24 minus y 0.46 is 0.54, which is 2.7. So it's the centigrade. We find the theta here, we get the theta here is 24.23. And then all I had to do was to find the force, the sum of force Fy is the same thing. This minus this minus this. You get here 22,362.8 sine 84.86 minus 1 minus FDS cos 24.823. FDS cos 24. So it's this one minus this one minus this one, the resultant here. And then we get that FDS equals to 0 divided by cos 24.23. And then we found out at the end FDS is equals to 0 Newton, which means that as FDS is actually a zero force member that only acts as a support in the transmission tower.
Okay, for question 2, determine the magnitude of the gripping force produced when two 300 Newton force are applied as shown. We draw a FPD full. So we start from FPD1, we take moment at A, then we use 3 force, but BX is 0 force because BX cancel with each other. Taking moment at A, the force of F time with is horizontal length from A to F minus with BY time with horizontal length from B to A, which is F with time 0.024 minus BY we take 0.096 equal 0. So we get F equal 4BY. So FBD2 to find by we take this moment at C. BX we have force BX BY and 300 Newton. So BX we time 24 millimeter plus BY 12, we take 12 times 12 millimeter minus 300 times 448 millimeter equal 0. So that we get BY equal 11,200 Newton meter. So FBD3 BX equal 0, just the force cancel out each other. F equal 4 BY, so we get 4 F equal 4 times 11,200 force equal 44,800 Newton.
So for question 3, here's the bucket for the front end loader 3000 Newton. So let's keep all that. Okay, so here's the full body diagram. The full body diagram here is 1.5 kN because it says here that this 3000 Newton only supports half of it. The mechanism shown here supports half of it. So instead of 3000, you divide this 3000 by 2. So for FBD1, we take the first section, which is the upper one. Here we can find the moment at D, moment at here. If we found the moment at D, we can eliminate FDC and FDE to find FAB. So here 1500 times by its perpendicular length, which is 40 centimeter, equals to FAB times by its perpendicular length, which is also 40 centimeter here. So the force here and the force here, they are in the opposite direction, so they equals to each other. So we found here FAB equals to 1.5 K Newton, 1500 Newton. For the second FBD, we take the second part of it. We found since we already have FAB, we can find FDC, which is here, FDC, the force here. So I have this derivation of the resultant force. I also have E. We take the moment at E, so we can eliminate EY and EX. And all I have to do is FAB times by 0.6, which is the length here, So 0.6 meter, 3 centimeter. So it's 60 centimeter equals to 0.6 meter. Plus with FDC cos 21.8 is the theta that we can find it, times by 0.4, and plus FDC sine 21.8 times with its perpendicular length, which is 0.1, the horizontal length. So here we do the normal moment equation. You can find out that FDC is equals to 2695.4 Newton, and it's pointing in the opposite direction for my from my original three-body diagram problem. Since we found FDC, we can find the sum of fx, 1500 minus plus ex, plus 2.2695.4 times cos 21.8, which is here. Since I already found the force here, I have the horizontal force for here. I can find the ex here. And FAB. I have FAB. I have this force here, horizontal force for D, and I can find FE, EX. So here I found EX is equals to 1002.6 Newton. For EY, it's the same drill. I have EY, I have CY. That's all I need. So EY plus CY is the force CY equals to EY equals to 1000.98 Newton compression. And then up for the third free body diagram, which is the lower part of the whole body diagram. Here we are required to find FFH, and then support at GX and GY. So here are just simple mathematics. Find cos. These are all the forces that we found. With this sine theta, you can find it. We can find it easily. If the mathematics given, there is height, everything. So we take the moment at G. We can eliminate GX and GY. We can find that later. We take the moment at G. Now we're finding FH. So it's this one times with cos 31 times with 0.65 meter, which is the whole length here, I presume. Cos 31, yeah. So whole length here plus sine times 1.5 meter times this one times with each respective perpendicular length here, and then minus FFH for Fx and Fy. You can derive this. So here we can find out that FFH equals to 40,717.83 Newton. These here are all the kind of like moment. So we found the force here. We have the resultant force for X and Y for this one. We also have the resultant force of X and Y for this one. We also need to find the resultant force of Fx and Fy at the moment G times with each respective length. There is length given at the very beginning of the drawings. There's the length given, the times with each respective length. And then from here, you can find the answer. That's how you find the moment at G. You find the FFH, and then here we find the last one that we need, which is pin support at G at GY and GX. GY, you use the equation of equilibrium, sum of Fx. GY, you use the sum of Fy. So GY plus with this, plus minus with this, these both, if you look at the picture here, GY, the whole diagram here, there's only 1, 2, 3, 4. 4 forces. So GY minus Fy cos Fy sine, whichever theta I can find here. You can find the theta here. This is how you find the theta. This minus cos 45 plus cos 45. This is the theta. You can find the theta here. You have the length here. You have the length here. You can find the theta here. FFH cos 45. And then minus this one. 1000.98 Newton, and then minus this one, 2.69 2695.4 sine 21. And if you're wondering why is the drawing here and the plus minus here is reversed, is because of the thing up here. I found here FFH equals to negative 14,000, 14 K Newton. This is my original drawing. So for finding GY here, I had to readjust readjust my arrow. So the arrow at here was pointing up. That's why it's plus plus minus minus. GY plus FY minus EC and then minus D. You can find this. FX, the same thing goes for FX. GX plus with FX here, minus with here, minus with EX and DX. And then you can find GX equals to 13,912.31 Newton. This one is 10.
Okay, proceed. Question 4. Okay, for the question 4, the question is ABC is connected by pins, what coil at B and crank at CD at C, neglecting the effect of friction. Determine A, couple M, force at B, pin which is pin B, C, which is pin C, and D, support pin D. Required to hold the system in equilibrium when theta is 0 and 90. So we look at the picture here, and then we proceed to the FBD full here. Then we proceed to the FBD one, which is we got the theta which equal to 0, and then we derive the moment at moment C, which is the equation is moment C equal to 0, then 240 Newton here, time by the length at the vertical, and we got the final answer is By equal to 750 Newton. And then we derive the force, which is force X here, equal to 0, and then we take the Cx at the point C, minus by 240 equal to 0, and then we got the final answer is Cx equal to 240 Newton. And then we go to the for the force at Y, which is the equation is Fy equal to 0, and then we take the point at point C, which is Cy, minus by the By here at the point B equal to 0, and then we got the final answer is Cy equal to 750 Newton. And then we go to the FBD2, we derive the for force X FBD2 Fx equal to 0, and then we take the Cx here at the point C, and then dx at the point D, Cx minus dx equal to 0. We got the answer dx equal to 240 Newton. Then for force at Y, which is the Fy equal to 0, and then we take the Cy at the point C, Cy minus by the dy equal to 0, and then we got the final answer dy equal to 750 Newton. And then FBD2, find the moment, which is moment D at the point D here, moment D equal to 0, and then moment D equal to 240, which is the force here, 240 Newton, time by the length, minus by the 750 Newton here, time by the length horizontal. And then we got the moment D 30 minus 235, and then we got the final answer negative 195 Newton meter. So we go to the FBD4, which is the theta is 90 degree, and then we got the moment C equal to 0. And then we take the force here to negative 240 by time by the length horizontal, and then negative minus by By time by the length vertical. Then we got the By equal to negative 375 Newton. And then we derive the force X equal to 0. Then we got the Cy equal to 0 Newton. Then we go to the force Y equal to 0, and then we took the Cy at the point C plus 375, the length 375 minus by 200 40, and then we got the Cy at the point C is negative 135 Newton. Then we go to FBD5. FBD5 we derive the moment force X, which is Fx equal to 0, and then we take the dx here at the point D minus by 0 equal to 0, and then we got the dx equal to 0. And then we take the force y. Force y, you can look at the FBD, Fy equal to 0, and then we take the dy here, dy negative dy minus by 135 equal to 0, and then we got the last answer is dy 135 Newton. Then we look at the moment equal the equation is md equal to 0, and then cx which is here time by the length vertical here up there, and then plus 135 is force there, and then time by the 300 length there, which is cx equal to 0 Newton, and then we got the last answer is moment D 40.5 Newton anti-clockwise. We move to the question 5. The two hydraulic cylinders control the position of the robotic arm ABC, knowing that the position shown the cylinder are parallel, determine the force exerted by each cylinder. Okay, B by pin C at support, when P 250 Newton and Q 150 Newton. Okay, we start with the FBD full. FBD full here. We got the FBD full here, and then we derive the force at y, which is Fy equal to 0, and then we Ay at the point A equal to By plus 250. Okay, then we got the last answer here, Ay equal to 1000 Newton, and then Fx we take all the Fx force at the FBD, and then take the Bx, and then we derive the Bx equal to 150 plus Ax plus Bx, and then we got the last answer is Bx equal to 900 Newton. And then we derive the moment here, negative By times by the length, then minus 250 times by the length, and as we can see at the FBD minus by equal to 0. Okay, and then we got the final answer, By equal to 150 Newton. And then we go to the FBD2. FBD2 derive the moment here, which is a moment E at point E, and then we derive the Ax time by the 400, and then we already got the a value here, and then takes Ax equal to 750 Newton, and then lastly we derive the force in the cylinder EA and the force at EA, and then A equal to 700 times by 700 square plus 1000 square, and then A equal to 1250 Newton, and we got the force of the cylinder is 1250 Newton. Okay, next we move to the next FBD here, and moment F. Okay, moment F equal to 0, and then 900 times by the length, minus by 1250 times by the length here, minus by FGD equal to 0, and then we got the final answer FGD equal to 93.75 Newton. Then we move to the next FBD here, we derive the fx equal to 0, and then we take the equation from the FBD is Fy minus 1250 plus 93.75 sin 53.1 degree equal to 0, and then if we got the final answer, Fy equal to 1775 Newton. Okay, then for the force x, the equation is Fx equal to 0, and then Fx plus 93.74 cos 53.1 degree minus y minus by 900 from the equation from the FBD here. We got from the FBD here, and then equal to 0, and then we got the final answer if Fx equal to 843.78 Newton.
Okay, so this is it for our group's presentation. Thank you very much, sir, for listening to us.